In this video, we take a look at finding roots of complex numbers. So if a complex number has the name of z, and it's in the form of r bracket cosine theta plus j sine theta, so this is this trigonometric form, a complex number is the number z then. We can find the nth roots if we use this formula below. So the nth root of z would be found by finding the nth root of r, and then in the trigonometric form, the cosine of, let's do this all here to the angle, theta plus 2 pi times k, all divided by n. Or if we are working in degrees, of course, we would use 360 degrees times k, all divided by n. And plus j sine, and exactly the same thing happening to the theta in that case, where k is equal to the numbers from 0, 1, 2, and so on, all the way up to n minus 1. So this is determined by whichever root you are looking for. That means if you are looking for the fourth root, that would look like this, then we would use for k equal to 0, 1, 2, and 3, because 3 is 4 minus 1. So what this does for us is it gives us 4 different versions of the root. That means for the fourth root, we will have 4 roots. Okay, so whatever number n is, it will indicate the number of roots that you will find of the complex number. All right, so let's take a look at an example. Find the square roots of z equal to 9, bracket, cosine 20 degrees plus j sine 20 degrees, end the bracket. So square roots, we are finding the square root of z. Therefore, our n equals 2. So that means we must use k equal to 0, k equal to 1, and stop there. 1 is equal to n is equal to 2 minus 1, our n minus 1. So those are the two values we will use to find the 2 square roots of this complex number. So let's go ahead and we'll notice that our r is 9, our theta is 20 degrees. So instead of 2 pi, I'm going to use 360 since it's in degrees, okay? All right, so if k equals 0, then one of the square roots of z is equal to the square root of 9, bracket. Now let's use a square bracket. Cosine, we've got our theta is 20 degrees plus 360 degrees times our k, which is 0, divided by n, which is 2. We'll write the same thing for the j sine, and I will do 20 degrees plus 360 degrees times 0, all over 2, and n the big bracket. All right, so let's tidy that up a little bit. One of the square roots of my complex number z is equal to 3 cosine. What do we get in the numerator there? 20 degrees plus 360 times 0. Well, that's a 0. So 20 degrees plus 0 over 2, which is 20 degrees over 2, which is 10 degrees, plus j sine 10 degrees. And that is one of them. Let's just see how that looks if we graph that. Just a rough little sketch of the imaginary axis and the real axis. We've got an r of 3 and a theta of 10. So I'm just going to put that, I'll make that look as close as I can to 3 on that and 10 degrees in there, okay? Now, we also have to do for k equals 0. So for k equals 0, the square root of our complex number z is equal to the square root of 9 times the cosine of 20 degrees plus 360 degrees times 1 now, all over 2, plus j sine 20 degrees plus 360 degrees times 1 over 2. Let's see what that works out to. It's a 3 cosine. Okay. 360 times 1 is 360 plus 20, 380. 380 divided by 2 is 190 degrees plus j sine 190 degrees. Let's graph that. All right, so we have our imaginary axis here, our real axis over here, and we have a r of 3 and a theta of 190 degrees. So this one goes opposite to the first one that I drew, 190 degrees for theta, so 10 degrees past here, and this is a 3. Recall that the other one was up this way, right? That's the first one. 10 degrees in there. And the 3's, well, let's make them look the same length because they should be, they're both 3. Good enough. Okay. Notice that, so we're doing a square root of a complex number. Since it is a square root, we achieve 2 roots, and they are evenly spaced around the circle. So they have 180 degrees between them. If there were 3, there would be evenly spaced as well, 3 different terminal arms equally spaced amongst the 360 degrees as well. So that would be 120 degrees between them. And that's just a feature of complex numbers. So thanks for watching.